Okay, forget about this square root of a squared plus c squared when we go over here, because this also involves a's, b's, and c's, and doesn't involve an a squared plus c squared, but it involves something much like it, so you got to be careful. Okay, the question is, the sun is at the focus of an orbit of some planet, or in this case probably an asteroid, because the asteroid's out there, between, around 4 AUs. Remember, an AU, and I didn't put the U in my AU here, an AU is an astronomical unit, which is the mean distance of the Earth from the sun and its orbit. Okay, so this is an asteroid that's got a slightly eccentric orbit. That is, the major axis is 4.2 AU, the minor axis is about 20% less than that, about 15% less. And I've exaggerated the elongation of this ellipse. It's much closer to a circle. But if I drew it that close to a circle, you'd think I just didn't draw a good circle, which is usually the case. Okay, so the sun is at the focus of the elliptical orbit. And then we want to get the equation. So we're going to assume that we don't put the origin of our coordinate system at the sun. We're going to put it at the center of this ellipse, putting the ellipse into the simplest standard form. Now there's a polar form of the ellipse where we would put the pole at the focus, and that's also a very important form, but we're not emphasizing that right now. This will be enough to handle, because as we see, people come into this course without having covered the stated contents of the prerequisite course, and that often includes conic sections. Okay, so what do? We want to write the rectangular coordinate system equation of this ellipse, so we put the origin at the center of the ellipse. And we know that x squared over a squared plus y squared over b squared equals 1 is the equation of an ellipse whose semi-major axis is A, whose semi-minor axis is B. The ellipse that could be easily sketched within this rectangle of dimension 2A by 2B, centered in the middle of the rectangle, at the center of the rectangle, okay? Same as the center of the ellipse, because of all the symmetry. Okay, well, so A is what we call the semi-minor major axis, and B the semi-minor axis. Now, of course, turns out we could, if the ellipse has this form, could be the major axis of a certain ellipse is in the y direction, and then B would be our semi-major and A the semi-minor axis. There are different naming conventions and different letter conventions depending on who you look at. In any case, here's the equation. So for this particular ellipse, what's the value of A? Well, it's half of the 4.852 AUs, which is 2.26 AUs. So we replace A with 2.26 AU, and we replace B with half of the 3.82 AU, the 1.91 AU, and right there is the equation. And then I'll say the sun is at the focus, and the focus is, the way I've drawn this, if the sun is here, it's at negative C, 0. Okay? Now, C is the square root of A squared minus B squared. It's going to be less than A. Okay? Now, if the major axis was B, it'd be square root of B squared minus A squared, and we could actually write an absolute value sign there, and that would cover the possibility that your longer axis is in the y direction. The focus does go on the major axis, so if the longer axis was in the y direction, the focus would have to go on that axis. And there are two foci. There's one here, one here. And in case you don't remember, a focus is a point such that the sum of the distances, both focuses 2 points, such that the sum of the distances from between the two foci and any point on the ellipse is always the same. And we've talked about that, so I'm not going to emphasize it now. What I do want to talk about a little bit, though, is the eccentricity. So let me come back to that, because it's a very simple quantity. It's very simply involved with the distance of the focus from the center and the length of the major axis. So we'll come back to that in just a minute.